Hello folks, it's Ms. Strong here, ready for another demo video I hope. We're working on homework 5 today. Let's get going. Some of my favorite questions. They're true-false questions and they are here to confuse you. So let's be careful with them. First one, true or false? When you add two numbers with different signs. So there's only two possible different signs. Something can either be positive or negative. So basically we're saying when you add one positive and one negative number, the answer is always negative. I hope you know that that's not true. This is false. The reason it is false, and we can show an example, or when it's false, we call it a counter example. When negative 2 gets added to a 3, we get positive 1. So there's a counter example. There's two signs or two numbers with different signs that add together to give us a positive number. In other words, whether I get a positive or a negative number in addition and subtraction depends on which number is larger. So there's an example where I get a negative, and there's an example where I get a positive. The next one, true or false, when you multiply two numbers with different signs, the product is always negative. This time they're asking us about multiplication. When you multiply two numbers with different signs, again, that means one's going to have to be negative, the other one's going to have to be positive. The product, which is an answer to any multiplication problem, is always negative. This time, it's very true. Why is it true? Because anytime you're multiplying, we say that a negative times a negative is a positive. So if you have one negative sign and nothing to negate it, then your answer is going to be negative. Right at the bottom here, true or false? A negative and a negative are positive. This is one of my favorite questions that ninth grade students ask. The answer is false. And I think we showed that in the first two questions. A negative and a negative are going to be positive if you're multiplying. But if you're combining, a negative and a negative are going to be a bigger negative. So combining is like saying, I owe somebody one amount, I owe somebody another amount. You still have a negative amount that you owe. Multiplying is that not. It's that not going to the store, so you're going to the store. Multiplication cancels every time you have two negative signs. Here's another place where negatives might get in the way, and I wrote this at the top just to help you understand. Negative 2/3. That means negative 2 divided by. Remember how your calculator uses just a fraction bar for division? You'll never see that line with two dots on it in your calculator, and you'll hardly ever see you use it. You just don't use it anymore. It's not very helpful. What is helpful to understand is that if it's negative 2 divided by 3, it's the same as putting that negative sign in the front and saying that, well, I know that when I divide a negative by a positive, I'm going to get a negative. And it's also the same as letting that negative sign fall to the bottom. So often we put the negative sign where we want it, where it's convenient at the time. We don't want to put more than one negative sign in, but we are allowed to use it from top to middle to bottom. So all that said, let's kind of focus on this guy right here for a moment. This is a multiplication problem. And if you put this guy in parentheses and put this guy in parentheses, you can pop this thing in your calculator very, very easily. I don't really recommend that. It's a nice way to check. The reason I don't recommend it is multiplying fractions is not only not too difficult, but it is a place where your calculator can slow you down instead of speed you up. When it comes to adding fractions, your calculator speeds you up because you need these common denominators and it takes a while. But multiplying is really pretty straightforward if you use the little hint that I'm about to give you. So let me remind you that when you multiply fractions, you are saying both numbers on the top, or even if there were a whole string, it'd be all the numbers on the top if there were lots of fractions being multiplied together. All the numbers on the top get multiplied, and all the numbers on the bottom get multiplied. And I think you know that when we're finished multiplying, the last step is going to be to reduce our answer. And that's where I'm going to help speed you up. So hang on, I'm going to do it. This is the long way. Negative 3 times 2, negative 6. On the bottom, 5 times 3 is 15. Well, when I look at that, 6/15, I could either plug it in my calculator to see that it will reduce, or I can just look at it and go, oh look, 3 goes into 6 2 times, and 3 goes into 15 5 times. And that makes my answer 2/5, or 2 divided by 3. I simply reduced it by 3, or I divided out that 3. And I don't want to lose my negative sign. My answer is still negative. Sorry. My answer, I'm going to try that again, negative 2/5. Negative I need, 2 I need, 5 I need, and what's on top, and what's on bottom. So, okay, Liz Strong, I did that a long time ago. I know how to do that. Now, how are you going to make it faster? Here's how. That last step, divided out of 3. So in essence, you're multiplying 3 times 2 and then dividing the 3 out later, and that's double the work. What if you noticed right here that this 3 on top and this 3 on bottom reduced right out? What if you noticed they matched and they reduced to 1? Just like when we have x on top and x on bottom and we call that 1 and we reduce those out, the numbers work the same way. And I think what confuses students is you think since it's not right on bottom, that you can't like divide in this direction. But you can. The way I worded it is anything on bottom reduces with anything on top. It's actually the commutative property that tells us that. It tells us I could put the 3 first and the 5 next, right? And then one would be right underneath the other. It would look better, but we don't need it to look good to work. So in this problem, what's left? 2/5 and the negative sign. And I got there quicker because I said, I don't need to multiply and then divide. I can divide first, and then all I have left is the 2/5. Or sometimes I still have to multiply, but I don't have to divide after I've multiplied. Okay, again, do them on your calculator if you need to, but this is the best and shortest way, and it's the way that's going to be the most helpful to you in the future. So you have quite a few word problems in this assignment, and I need you to read them very, very carefully. They're not difficult problems, but sometimes you read too much. You try to make it too much math instead of more. Does that make sense? So I want to caution you to be careful about these questions, but to be careful in this way. Don't forget that everything is logical and makes sense, and use what it's telling you to make sure it's making sense. All right, my words are not so great. You earn $537 a week in gross pay, and 2/5 of your check is going to be taken out for taxes and deductions. How much of your check is taken out for taxes and deductions? Well, they just said that it's going to be 2/5 of this. So remember that the word of in mathematics is to multiply. So what I need is 537 times 2/5. I always do this like this, put 1 on bottom. I look first to see, can I divide that 5 into anything and make it smaller? It turns out I can't. So the only way to do this is, well, not the only way, but the way I'm going to do it is with my handy dandy trusty Mr. Calculator. 537 times 2. That gives me 1,074. 5 times 1 is 5. So far, I just multiplied the tops and multiplied the bottoms. The last step is for me to divide 1074, because that little bar means divide, right? Divide it by 5 again, just pop it in my calculator, and I get 214.8. Now, I need to go back and read the question because it's important that I answer the question I was asked, and I need to make sure I'm answering the right question. They might have said, how much of your money is left? Or they might say, how much are the taxes? So I need to make sure I'm answering the right question. This one says, how much of your check is taken out for taxes and deductions? Well, 2/5 of my check is taken out. I found 2/5 of my check to be $214.80. So I think that's a good answer right there. Make sure when you're doing your questions, you recognize that you might have to round up or round down to match the answer in the multiple choice. How about this one? While shopping, you found a sale for 1/3 off the regular price. If the regular price is $65.75, how much will be marked off the price? And it asks us to round to the nearest cent. So that would be to the hundredth place or 2 places past the decimal. In other words, make it look like money. I just need to find 1/3 of is that times sign, 65.75. So I'm finding 1/3 of that. What's happening? I am multiplying 1/3 times 65.75, but that's the same thing as dividing 65.75 by 3. I'm not even plugging that into your calculator. I'm going to let you do the math. 1/3 of that is going to be, and now I just decided I am plugging it in because I want to talk about rounding for just a second. So 65.75 divided by 3, and I end up with 21.91666, and the last digit in my calculator is 7. They want me to cut this off at money, so they only want this much of an answer. I notice that the first number I'm going to make go away is larger than 5. That tells me it's more than ½ cent, and so I need to round up to $21.92. And that's probably my best answer right there. You should see that as one of your choices if my numbers were the same as your numbers. Of course, I make my numbers a little different so you can do the problems by yourself in your homework. So, what's going on here? I hope that you see the distributive properties. Let's try to focus one at a time. When I look at this guy, I see a 2.7 outside these parentheses. That tells me I'm going to be multiplying it in like this. However, now I'm looking closer and look, I notice inside I have like terms. So yes, I can multiply twice if I want, but I think the better way to do this problem is going to be to call it 2.7 times what is 3y minus 5y? Well, it's negative 2y. So now I simply have to multiply 2.7 by 2. And be careful about my sign. So it's 2.7 times negative 2. If you do it in a calculator, you'll get negative 5.4. And this y guy is being multiplied. So I just set it right there to say this is multiplication. Remember that when I multiply, the terms do not have to match. When I add or subtract, I can only do that when I have exactly the same term. So y's adds y's. Y squared adds or subtract from other y squared. You have to keep the term matching. Next problem. This time what's in parentheses, if I look at this very next guy, these are not like terms. I cannot combine them like I did in the problem above it. All I can do is multiply, and I need to be very careful multiplying because I'm multiplying by a negative. So let's use our calculator, 3.4 times, and I'm going to go ahead and put in negative 2. Remember how I have to use that little negative with a parenthesis at the bottom? That way when I get my answer back, it's got the negative sign on it. So my calculator tells me negative 6.8 is what I get when I multiply 2 times 3.4. I see this x here, so I need to bring that x down into my answer. So here's where the sign gets missed quite a bit, so watch carefully. This negative guy is going to come over here and multiply by this negative guy. And I know that you tell me sometimes that that's not a negative sign, but that it's subtraction. And I tell you that a number being subtracted is a negative number. It's going away. So, yes, that minus sign is a negative times a negative. And a negative times a negative is a positive. So that sign is going to change. Now I just need 1.6 times 2. I could have put in my calculator negative 1.6 times negative 2, but I didn't bother. I simply knew that it would be positive, and then I said 3.2 is the number I get, and this y needs to fall down here. Lots of students who get this far then knock it up. They want to combine x's and y's. You cannot combine because x's don't match y's. In other words, I have negative 6.8 x's, and I have 3.2 y's, but I don't know about x and y together. Nothing. Just leave it. That's my final answer. Number 3. Oh, not number 3, but down at the bottom it said 3 dots, but it's really 3.2. Now this one can get confusing, and we need to think about PEMDAS here. Please excuse my dear Aunt Sally. PEMDAS tells me what I need to look at or focus with first. And it says that I need to do parentheses first. And I need to point out that it's not talking about this type of parentheses. This type of parentheses just means multiply. Up here, these parentheses are the things they want you to do first. They want you to look inside the parentheses and see if you can combine something together or simplify inside parentheses. So that's what they're talking about when they say parentheses, and they really are not referring to the ones that the parentheses that stand for multiplication. How about exponents? Well, so if I look at my problem, I go, okay, there's really no parentheses in here, just the ones that mean multiplication. How about exponents? There are no exponents. Those are those little numbers that come up on top, right? And there are none of them, so I've done my parentheses, I've done my exponents. How about multiplication and division? Well, when I look at my problem, I do see multiplication in it. So I need to do that multiplication before I do any addition or subtraction. Again, we have to watch signs carefully. Negative 4 times negative 3. That's going to be a positive 12. And I have this b here, so it needs to come down and be right there. Negative 4 times negative 3z is 12z. Notice that I can multiply terms when they don't match. I cannot combine terms when they don't match. How about this guy? He's just going to fall down and kind of be part of my problem. In other words, I do a little piece of it, and then I regroup and do another little piece. So now I have 3.2z plus 12z. And yes, they're both z's, so I can combine them. And 12 and 3.2, 12, 13, 14, 15.2, and z. There's my final answer. This guy on top, I'm back up at the top now. I know I'm flying by. Tells me I need to multiply over here, add only at the end after I've multiplied. Again, I'm following PEMDAS down here. I'm doing all my multiplication and division before I do any addition or subtraction. And this is a really classic problem that lots of people mess up on. So let's just be careful with it. I need to multiply 3.5 times negative 2. Well, it's a negative times a positive, so I know my answer is negative. And really, I'm just doubling 3.5, which would be 7, right? And I have two variables hanging out being multiplied, so I'm going to stick them right back down here, hanging out being multiplied. I do the same thing over here. I'm going to multiply negative 5 times 5.2. And I'm going to use my handy-dandy trusty nifty calculator. When I multiply those together, I get 26, but I notice that this guy is negative. So I can write negative 26, and notice again I got an x and a y, so here I'll have an x and a y. I see two negative numbers. They are like terms. They are both xy guys. Here's some xy's, here's some xy's. They match. I can combine them. I can also rewrite this just to point it out. Negative 7xy minus 26xy. Remember how when I have two signs in here, it's the negative guy that overrules. Either way is fine. You write it the way you like best. I do need to combine these two numbers. They're both negative, so I'll add them together. So what do I have, 26 and 7? I think that's 33. So when I combine two negatives, I get a bigger negative. Negative 33 xy looks like the good answer to me. Last one, and let's see what I'm going to do. I'm going to multiply here because I see multiplication. I see no exponents. I see no parentheses other than my grouping symbols, other than the ones that tell me to multiply. So negative 2 times 2.3, 4.6, and it's negative, and there's an x guy there. And negative 30x just falls right down to stay in my problem. Both of these are negative, so I'm going to add it together and get a bigger negative, 34.6x. Also, they were like terms. That's the other reason I added them together. They were both x's. All right, we're cruising right along. I think we might even almost be done. This is our last slide, and I'll switch through it as quickly as I can without being too confusing. We need to evaluate x times y minus 3.5 when x is negative 3, y is 1.2. So our first step, take out this x, put in negative 3. Take out this y, put in 1.2. When x and y are next to each other down here, we're supposed to multiply them. So when I have them at the top, I'm going to multiply them there too. Then I don't want to lose this 5.3, so I'm just letting it fly along in my problem or add along in my problem. 3 times 1.2 is 6. So now I'm multiplying 3 times 1.2. It's a negative 3. So it turns out that it's negative 3.6 minus 5.3. So I multiplied these two guys together, and then I just let this piece come right along. I have two negatives to add together, 5.3 and 3.6. When I add two negatives, I get a bigger negative, so I get negative 8.9. Let's try one more. Finally, we get one with exponents in it. A 3.2 is going to go in for that A right there. And watch how I write this. Negative 5. And then it tells me I'm going to square A. So I want to make sure it looks like I'm squaring all of A. And I'm going to do that with parentheses. What do I do first here? Do I multiply the negative 5 times 3? No. PEMDAS tells me I've got to square 3.2 first. So that means 3.2 times 3.2. When I do that, I get 10.24. Now I let this negative 5 fall right down, and I'm multiplying negative 5 times that 10.24. And yep, I'm using a calculator. Hope you do too. Nobody wants to sit and do long multiplication. We're beyond that. 51.2. There's my final answer. I like it. I think that takes care of what you need to know to be successful on this next homework assignment, homework 5. Please go get going on it. Glad you had time to watch. Ask questions when you have them. We're in TOGA. We're in morning office hours. See you later.